Hello, everyone. In this series of demos, I want to demonstrate some of the capabilities of JetStack Secure and how it can help get the visibility that you need for your Kubernetes environments around machine identities. You will get the status of all of the certificates, the ability to understand the configuration of your Kubernetes cluster, um, and see if there are any violations in terms of compliance and policies and things like that. Essentially, the idea with JetStack Secure is to provide you full visibility to all machine identities across all of your clusters, whether it's in a single cloud or across multiple different clouds. Accessing your account and setting up JetStack Secure is fairly simple. What I'm going to do is, or if you don't have an account, you can get started. But if you already have an account, just coming into platform.jetstack.io, click on Access Your Account. And I'm going to sign in with my JetStack account, and I will end up in a page that will show me the cluster summary. As you see here, if I didn't have any clusters, it would say no clusters found, and it will allow you to add a cluster. I do have a couple of clusters. Adding a cluster is fairly simple. You click on Add a Cluster, provide a name. As soon as you provide a name, then it will give you a command to run on your Kubernetes cluster. That will create the credentials and also all of the required resources for the JetStack Secure agent that we need to run in your Kubernetes cluster. As I've already taken care of it, you will see that I do have a cluster with the name JSS demo cluster. However, there is absolutely nothing that I've done in my Kubernetes cluster, so nothing is showing up here. Everything shows up as zeros. This cluster is, if I get notes, I can see that, this is a brand new cluster that I created just a little while ago, so about 12 minutes, as you can see. What I'm going to do is I do have a bunch of targets on my make file that I intend to run to demonstrate various different capabilities of JetStack Secure. And in order to do that, one of my first commands that I'm going to run is essentially to just create manual TLS secrets. And as you can imagine, I am going to create a standard secret resource in Kubernetes, but of type TLS, and see how that sort of manifests itself within the JetStack Secure. JetStack Secure tracks every single certificate resource, so to speak. The certificate resource is something that comes from Cert Manager, and Cert Manager essentially is the core to everything that JetStack Secure shows you. All of the information, all of the details about the certificates, everything comes from the using of Cert Manager. However, in this case, we expect not to see Cert Manager in use because we did not see anything that we did with Cert Manager. And as I refresh my screen in this cluster, you see that there are 2 total certificates that JetStack Secure discovered. However, both of them are not managed by Cert Manager. And that is shown in the form of a number here that shows not managed by Cert Manager. And additionally, it also shows any of the warnings or issues that you will have for each of the certificates. And obviously, from a health perspective, there are a few issues with this certificate. In addition to being self-signed, this also certificate has already expired, and because it is not managed by Cert Manager, there is no way for it to be automatically renewed and all of those things. The second cert also has an issue, probably similar to what the first cert had, but in addition to that, it also uses a key size which is not standard. So that is flagged as well. And as you can see here, JetStack Secure does a good job of demonstrating and showing you all of the certificates. In this case, though we have 2, and over a period of time through this demo, we will see more and more certificates sort of coming and landing in this certificate inventory page. So As the next scenario, I want to jump right into few use cases that not just shows the value of cert manager being used for ingresses within your cluster, but also how you use cert manager for part-to-part MTLS, and how do you actually use cert manager for your service mesh, specifically with Istio, and how do you essentially use Cert Manager to give that issue that certificates for your service meshes, and finally, I mean, obviously, all of that, and how does that manifest in JetStack Secure, and that's essentially what I want to sort of demonstrate and show. Just like I said, I do have various different targets in my make file, and my next one is going to just run this target called make verify TPP demo one prepare. It prepares the environment for various different things that I want to show you. But to begin with, it's creating a few namespaces, and also running a few resources that are created, and also generating few resources that I'm going to show you. The namespace that we're using for this demo is verify-tpp, and if I see that the paths in that, you'll see we just deployed a sample application, that will help us, demonstrate, how a certificate can be used in the context of an ingress. We did generate another file, or a couple of files, and I want to show you what those look like, and also show you what that means from Verify's perspective. One of the things that we created is this issuer.yaml, and as you see here, issuer for a verified TPP looks different than an issuer for something else, but the basic idea of an issuer in Cert Manager is that every time you want to configure something that will give you a certificate, essentially issue a certificate, you create a resource of type issuer. The issuer typically is namespaced. There is also another type of resource called a cluster issuer, which can be used for the entire cluster. And Cert Manager supports various types of issuers, whether it's Verify, Let's Encrypt, Google Cas, Cloudflare. There are a lot of different issuers that can be used within Cert Manager. It could be Cloudflare, it could be HashiCorp Vault as well, for that matter. And each of those issuer specs are different. And in this case, the Verify specification says that it needs to provide me a zone, a URL for the instance, and a CA bundle to connect to that. So now that we saw what it is, I'm going to just create that issuer by running that command, and it will create an issuer that we can see within that namespace. In addition to that, we will also create a couple of resources. One, the certificate, and then configure the ingress for this application. We did have a few more, as you saw. A few more files that we wanted to create. There is a couple of things here. There is a certificate-bad.yaml and certificate-good.yaml. There is an Ingress Tls. There is an Ingress and issuer. I'm going to run these and then show what happens, and what that means from a perspective of Verify, and also from JetStack Secure. I'm going to run the first one, which is certificate-bad, and as you can imagine, the name says bad, so something bad must happen, and we'll see what is that. And I'm also going to run the good, and obviously, as the good says, the good thing should happen with it. There is the Ingress TLS, which essentially will utilize the certificate that we are creating now and binding it to the Ingress, so that when the application is used, we have secured it with the certificate that was issued by Cert Manager with the configuration that was set with the issuer. A couple of things that have happened here. We see few resources that are getting created. One, which is the certificate that was created with a certain domain, the other one with another domain. One says false, another says true, and we will find out what the issue with that is. The resource certificate itself is here because we have Cert Manager installed on this cluster, and certificate and the companion resource called certificate request is part of the the Cert Manager's installation. We can try and find out what is wrong with this certificate request is by simply describing it. Um, and there is something that it says that, Venafi TPP is not allowed in this policy. So there were some policies that are defined by the issuer, by the configuration, in this case on the Venafi side, that does not allow certain domains, in this case, a domain called .net.com, which obviously seems wrong. And then that was the wrong certificate that was created. On the other hand, if you look at the first certificate, which is of status true, that is a certificate that has been issued. And then we can also look at a secret. And as you see here, one of the secret is created, the other one doesn't have a secret. And that's because, as you notice, that the certificate request was false and certificate resource is tagged as false, which essentially means that there will be no Kubernetes iOS TLS secret created for that certificate request. The one which you will see created are the ones which are always successful. And now going back to JetStack Secure real quick, and when I refresh this page, I should see some of the newer resources that were created. And some of the newer resources that you created also adds to the total number of certificates. We went from 2 to 4 now. And in that, one says ready, the other says error. And obviously we can click on that to see what is the good one look like. The good one says the health is ready. The usage says that it is not in use. Obviously, we just created a certificate resource, but we did not put this certificate to use in any way. It was issued, as you see here from the date, April 10th, it says, and then it will expire on July 10th from the date that you see. Certificate that is with error, it is providing us few information, secret missing TLS. Obviously, we saw that the secret wasn't found, and the secret not found itself is a symptom of some other error. And the error here is a policy violation that was caused because the common name or the DNS name for the certificate that was requested was incorrect. Which essentially translates to none of the certificate information provided here, but the idea that there could be errors. And this is something that you will probably see very often as you sort of look at various different certificate requests that are coming in from different teams. Some error, some ready, but at least this gives you information about all the certificates that are there in place. I can also switch really quick to the Venafi platform, which is where the certificate was issued. And we can go and check what happened there. And from this was the certificate that was issued, as you see on expiration is July 10th, and this was the certificate that was issued on 4/10. So you do have all of the various different policies and things that you can manage in the Venafi platform. The certificate is put in use here. As a third piece, since as the certificate is not in use, and I want to make sure that we get into a situation where the certificate can be put into use. And in order to do that, Venafi TPP demo 1, and I'm going to do. I'm going to just quickly show you what this is. What we're trying to do here is utilizing that same certificate and creating an Ingress resource to the application that we have in place. The only difference that you'd see from a typical Ingress is that we have added the TLS specification as well to this Ingress. And I'm going to just run that. And this is the this is the TLS that we have, and I can quickly go to this endpoint, and we should be able to hit that endpoint. This is a replica of three, the deployment that we have in place. So as we sort of go through that, you will see that the part name getting printed, the certificate itself is something that was issued, as we already discussed, on April 10th, and then it expires on July 10th, as you can see. That is the demo that essentially demonstrates how you can utilize Cert Manager for your ingresses, and how JetStack Secure provides you that visibility around what this cluster is doing, and how the certificates and machine identities within this cluster are managed. Additionally, you will also see that there is capabilities around the health of the cluster itself. This cluster that we've just created, it shows different things around what the cluster is, and it talks about 37 failures. So it is doing a check on various different policies based on OPA that we have in place, and talking about various different violations that it is seeing in the cluster, and you can configure this to your own sort of policies that you want to have. It's talking about things that are passed. It's talking about things that are of low things, and it's also talking about various different violations, so to speak, across all the namespaces, whether it is kube system, the Ingress, or the Venafi TPP namespace that we had. It also talks about how you can remediate some of the things that we are showing here. In this case, it's talking about the guaranteed QoS. In some cases, it could be talking about it's saying runs privileged workloads, what you should be doing, set the privilege to false, things like that. It is going to show you and help you sort of figure out what is happening within your cluster. That is the pre-flight aspect of JetStack Secure, that will show you all of the violations and all of the policies that you have defined, and which of them are passing and which of them are not, based on different categories. Some are related to memory, some are related to CPUs, as you can see, some are related to probes, and some talking about what kind of escalation of privileges that you have for the various different resources within the cluster. So that's two aspects. One which shows us machine identity, which is showing the cluster summary and everything. It is also showing us some information about the cert manager that is in CertOrg and the version of it. There is a latest version, which is 1.3. This cluster has 1.2. It's recommending that that I upgrade to the latest version of cert manager to get even more capabilities for my cluster. In my next demo, I'm going to switch focus to a slightly different scenario, which requires pods to have their certificates that are issued by Cert Manager. The idea being that when you want to secure pod-to-pod communication with a certificate that is locally available with private key and everything generated ephemerally for application use, you would typically want that certificate to be associated with the pod itself. And Cert Manager CSI plugin driver helps you ensure that a certificate is issued directly to the pod that you can utilize. When you install Cert Manager, by default, you may not see some of the other parts like the Cert Manager CSI parts that you're seeing, and that's because the Cert Manager by itself is almost, you can think of it as the core certificate management tool, and then there are additional capabilities that are brought in with the help of, for example, Cert Manager CSI driver plugin that will allow you to manage certificates within a pod. And through the part of this demo, I will also show you a few other scenarios that will add more things to the Cert Manager namespace that will allow you to do even more things. In this case, what I'm going to do is now run another target. In this case, a demo to prepare, as it says. and it's going to set up my namespaces as well. Most likely nothing will change in any namespace because we haven't created any new namespaces. Um, in this specific scenario, I'm going to deploy an app, which is, I can show you that one, TPP demo 2 deployment. Now, a simple app, actually made of the basic box. The only difference is, in the volume configuration, you see that, there is a CSI, and then the driver says cert manager IOCSI. There are certain volume attributes. It says issuer name. Now that we have gotten a little bit familiar with what a cert manager issuer is, it is referring to the name of the issuer. It's also referring to the DNS names that I want to use for this certificate that will be issued into the pod. The image itself, obviously, as you can imagine, is not relevant from the perspective of this demo because I'm using BusyBox, but almost imagine that this will be some user-developed application that will be utilizing the Cert Manager CSI driver. And in order to do that, we're going to just create the issuer first. As you can see, I have two issuers that I've created. The second one is the one which we just created, -2, 6 seconds ago. Now I'm going to deploy the application. Okay, get pods, -n, -tpp. And it's still creating, so let it create. What I want to do right now is at least quickly run the command to get the pod certificate. Let's see, it is in running state. As you see, I can do I've got some quick commands to just get the So what you're looking at here is, I'm looking at, I'm doing an exec into the pod and then doing a cat on the TLS cert PEM into the app with the label CSI app. Essentially, this pod contains the certificate. So every time we sort of, kill this, bring it up, a new certificate will be issued. And as we are using Venafi for this, I can go back to the Venafi platform again. And in this case, this was issued by, this is the certificate that was issued. As you can imagine, this was again issued on 4/11, and I believe the expiry that I have is probably in minutes. No, actually 1 year, it looks like. Okay, so that's essentially what the certificate is issued for. All of the information that you see here shows about it's from the Microsoft CA that is part of this infrastructure, Venafi infrastructure here. Again, a scenario that is also very common, use of Cert Manager and how people use it. Going back to JetStack Secure, we will see so that Check Secure is actually showing us, various certificates that were issued for this, and from this perspective, it's actually an ephemeral certificate request. It doesn't have a certificate resource, so to speak, that is represented here. So you will see all of these certificate requests that are temporary, just sitting there, and you can see that from certificate requests. This is the name of the CSI. That was the certificate request that was issued just now. In this demo, I'm going to use Google Cas. And if I switch to my, right here. So I have a new certificate authority that I created in Google Cloud Platform. And I have no certificates that are issued want to utilize Google Cast, similar to how we did with the previous demos, essentially setting up a issuer, setting up a sample application, and using that within the context of Google Cast. Since we've seen what it means for how the flow goes and what it is, and it's similar. I have another target I'm going to create. There is there's one bit of difference between the issuers that we created earlier and the issuer now that I'm creating now. The cert manager had notion of issuer and cluster issuers, as we spoke earlier. What this brings in is a slightly different kind of an issuer, which is called Google Cast Issuer. And one of the first things that happened as I ran this target was there was a Google Cast cluster issuer CRD, a Google Cast issuer CRD. Those were created a few RBACs with cluster role binding. All of those that got created essentially to help with this demo. So what we're going to do is next, and as you see, I ran all of this. The Google Cast issuer itself was created. We created a new certificate, and then we configured the TLS just so that I could speed up this demo and everything. But if you look at the Google Cast issuer-n/Google Cast, that's the namespace we are using. So this was a new issuer that was created, and you will see similar certificate resources, certificate-n, Google Cast. This was a brand new certificate that was just issued. There will be a representing certificate request as well, as you can imagine. And I can go back to my certificate authority service here, and then this is that. And then you see here, this was a certificate that was just issued April 11, that's about 2 minutes earlier from the date that you see on my desktop. And this is issued to Google Cast my domain, and that's the certificate that you have. We also created an ingress, and that was for the deploy that we have, which is the same web application, and I can go to that. This is a private CA, so expect this to throw an error when we go there because we are using the Google Cast private CA, and it's going to say it's not trusted, obviously. But I can look at the certificate details, and it is from the private CA, and all of that information that you expect to see. Obviously, I can go and proceed, and it'll show me the same sort of a behavior around how the name of the part changes every time I refresh. So this is another scenario where we actually used Google Cast as an issuer to manage certificates within our cluster. Similar deal, I can hit refresh here, and this will show me additional certificate information. As you see, I now have 5 certificates, and each one of them are in different namespace, which is why you're seeing it this way. So there's one in Unify TPP, there's one in Google Cast, there's another insert namespace. And this was the one which is now used in an Ingress called Google Cast Demo 2 Ingress, and it is bound to this domain and the certificate requests that were created. And as you see, if certificate requests take time, it will create more certificate requests. And one was deleted, the other one is ready. As you see here, all of the information about the certificate itself. Additional issuer here that we see in the Google Cast is a Google Cast issuer, as we found out. And here, as you see here, there are additional certificate requests that are getting created. As you get deleted, they all go away. So you see a representation of all of the certificate requests as well here. In the next demo, we want to see how you can utilize Istio with Service Mesh, obviously, deploy an application and utilize Cert Manager as a way to issue certificates for your Istio Service Mesh. And in order to do that, same deal, I'm going to run another make target. In this case, this is going to do a bunch of things for me. One, it's going to configure, the Istio itself. it's going to set up the Istio CSR plugin, just as we talked about in a previous demo, where when you wanted to use the CSI driver, we installed the CSI driver for Cert Manager. So similarly, there is an Istio CSR driver that will get installed as part of the Cert Manager. And as we do that, we're also going to install Istio using an Istio operator that will turn off Istioid as the CA server and utilize Cert Manager as the as someone who will be issuing the CAs. So all of that will happen obviously when I run this make command, and it's pretty straightforward. It's essentially creating a brand new issuer, getting a certificate from Google CAS, and then creating, and it's also downloading the configuration file, and then it'll run processing the Istio core. As you see, I'm going to just pause for a little bit and then come back to show what's happening. A few things that happen. If you look at, we now have a few more things here. As we just talked about, a while ago we had the Istio CSI, and then now we have Cert Manager Istio CSR. Can almost look by the various different things that are installed. The Cert Manager and the CSI driver were installed together. We installed the Google CAS as part of a demo about 10 minutes ago in the previous demo. And now we installed the Istio CSR that has been brought into Cert Manager. So now you can almost imagine that Cert Manager CSI driver plugin, Cert Manager Istio CSR, Cert Manager Google CAS issuer, all of this essentially enriching your ability to use Cert Manager for multiple different use cases. There were a few things that happened here as well in the Istio system, and I can go to Istio system. You see here there was an Istioid certificate that was issued, and this was issued by Cert Manager. The TLS secret that represents this. We can go and do paths -Istio system. It's no different, so you've got the Istioid, you've got the Istio Ingress gateway, Ingress and Egress, all of that is sort of deployed and running. There is also Istio CSR namespace where we have deployed the standard book application, which, as you can see, is utilizing Istio and issuing certificates and all of that. A few things that happen here, in addition to pods, I can go and look at certificate requests. These are all the Istio certificates that were issued for the application that is running in the Istio CSR. Because we are utilizing Cert Manager, all of those are represented in the certificate request resource. And we can go and describe one of them. You will see that it was issued here, but one point of note that you can use as a way to identify is to see which this annotation around identities tell what was it issued for. Now we picked one of them. Let's pick something else and see what that shows. And if I scroll up, this was issued for the book info product page. So this is the SPIFFE ID that shows that what certificate this was issued for. All of that sort of representing how Cert Manager is managing all of that. We can go back to the JetStack Secure page, and obviously we will see all of those certificate requests down here as well. As you see, all of that ready and available, and it is showing all of the certificates that have been issued and available in the Istio system for the service mesh to function. That's essentially how the Cert Manager Istio CSR driver works. So you can use Cert Manager one for ingresses, you can use it for pod-to-pod TLS, you can use it in the context of the service mesh where you have the certificates that are issued by Cert Manager for this. All right, so Kiala is up here and it's showing me all the information that we expect to see. Let's look at the STS CSR namespace. Let's also add security. We don't have anything showing up because let's run some requests. So you're looking at the source principle, the destination principle, and how each of these SPIFFE IDs map to the certificates that was issued by Cert Manager. That's essentially what Kiali's graph is showing us. You can click on any of this padlock and hover over both the source and the on the target or the destination principle. And this is telling us, um, the fact that each of these touch points or the connections are MTLS enabled, as you see, and we know that we have configured Cert Manager to be the one who can issue the certificates, and all the certificates are issued via that. That's essentially what you're seeing here. If we switch to JetStack Secure, you won't see anything different. Just to cluster names that we saw before, and if anything, because we have a few more namespaces, you should see all of the compliance that was applied to those namespaces also show up here. That is all we've got for demo today. Thank you so much. Appreciate your feedback. Please sign up at platform.jetstack.io for your own JetStack Secure account, tie it into your cluster. We look forward to hearing back from you and your experience of using Cert Manager and JetStack Secure within your Kubernetes and OpenShift environments. Thank you so much.